Starting on page 15, section 1.3 covers 3 different topics, the first of which is a midpoint and segment bisection. So in order to bisect a segment, we need to cut it in half. And I told you all that there are multiple ways a segment can be bisected. First and foremost, they can give you a midpoint, or they can give you the tiny little matching hashes to tell you that it is a midpoint. They could have a ray R, and tell you that it bisects the segment AB, or it can be bisected by a line. If any of these cases occur, it tells you that it's a midpoint or you have anything that bisects. We know that these two pieces, AM, segment AM, is going to be congruent to segment MB, which means their values are going to be equal. So that means I can take AM and MB and set them equal. And AM is written as 4x plus 1, that is the value. And MB is written as 3x plus 3. So from there, I can solve for x. I can solve for x by combining my like terms. I'm going to move my x's over to the left side, so I'll get x, and then I'm going to add 1 and get x equals 4. So once I get my x value, if I ask for, well, what's the value of AM? You can go ahead and plug 4 back in to 4x plus 1, since x equals 4, and get 16 minus 1, which equals 15. And that's about all you might have to do with a segment bisector. You might have to just take it one step further and find the entire length, which if this piece is 15, and we know that these two pieces are congruent, the whole thing, AB, the whole segment, is going to be worth 30. Alright, let's move on to the midpoint formula. With the midpoint formula, we are going to be given 2 points and those coordinate pairs. So if I give you that A is 1, 2 and B is 7, 8, and I tell you that those are the endpoints, we are able to take our x values and add those together. So 1 plus 7, that represents x1 and x2, and then we'll divide that by 2 and get 8 divided by 2, which is 4. And then we can take our y values together, which represents y1 and y2. It doesn't matter which point we label as our first and second point in this equation. So I have 2 plus 8, which is 10 divided by 2, and that should give us our midpoint of 5. It might get a little bit more complicated when I give you the midpoint and one endpoint. If we are given one endpoint and the midpoint instead of 2 endpoints, we are going to approach the problem like this. Here is example 3 on page 17. This is part B. So we are given the midpoint and one endpoint. I know that my midpoint comes out to 2, 1. So let's just deal with the x's. Let's deal with the x's first. Well, I know that my result is going to be 2. And here's my one endpoint. That's my one x value, alright? So I take 1, because I'm plugging it into the formula, x1 plus x2 over 2, and I told you all that equals your x value of your midpoint. So x1, let's just say that's 1, and I'm not quite sure what x value is the other midpoint, or sorry, the other endpoint, and that is over 2. So the x value of my midpoint is equal to one endpoint plus the other endpoint's x value divided by 2. And we solve by multiplying each side by 2 so that those two just drop out. 4 equals 1 plus x, and our x value, after subtracting 1, our x value for our second endpoint is 3. And then we have to run through the same process with our y's. I know the y value for my midpoint is equal to y1 plus y2 divided by 2. However, I only have one endpoint. So my y value of my midpoint is 1, and that equals y1, which we're going to say that's the 4, and you're looking for your second y, divided by 2. Same process of multiplying by 2. I get 2 equals 4 plus y, and y equals negative 2. So our other endpoint, point K, is 3, negative 2. And last but certainly not least in this section is the distance formula. We have the distance from A to B is equal to the square root of x2 minus x1, that quantity squared, plus y2 minus y1 squared. So I take my x values and subtract, and then I square them. And then I take my y values, I subtract and I square them, and then I add those two pieces together, and then I take that square root of the whole number. So if I look at an example, and I have the endpoint of, let's go ahead and say that A is 2, 3, 2, 3, A is 2, 3, and B is equal to 4, negative 1. Let's go ahead and plug in our x values. I'm going to choose A to be x1, y1, and B to be x2, y2. So we need to be very careful with our signs here. Alright, x2 is 4, x1 is 2, so I've got 4 minus 2 squared, plus y2, which is negative 1, minus 3 squared, and the square root of that. And that's going to be my distance from A to B. So 4 minus 2 is 2 squared, plus negative 1 minus 3, that is negative 4 squared, square root of that, which is the square root of 2 squared is 4, plus the square of negative 4 squared, that's negative 4 times negative 4, which is a positive 16. That is equal to the square root of 20. And the directions might ask you to round to the nearest tenth, and that would come out to, if it's 4.47, rounding to the nearest tenth would be 4.5. Hopefully you found this video helpful. If you need additional assistance, please feel free to stop by early in the morning or after school. I will be available. Please email with questions. See you tomorrow.